हमने लीनियर मॉडल पढ़ लिया, लीनियर रिग्रेशन का लीनियर मॉडल। अब हम उसको जनरलाइजेशन की तरफ लेके जाते हैं कि अगर हमारा मॉडल जनरलाइज हो तो उसको हम कैसे जनरलाइज कर सकते हैं। कोई भी फंक्शन हमारे पास हो, चाहे वो लीनियर हो चाहे वो पॉलिनोमियल हो, तो हम उसको डील कर सकते हैं। तो जनरलाइज वर्जन ऑफ लीनियर रिग्रेशन, अगर हम आपको याद है तो ये लीनियर रिग्रेशन का ये फंक्शन था जो कि हमने डिस्कस किया था, ठीक है। फाइंड W so that f of x best fits given data। तो हमारा जो मेन एम था, और मेन एम was to find the best fits for the given data. This was our goal. Now our goal is to generalize, to get a generalized linear regression. Instead of single variable, let's use predetermined function of x, such as h of x. So for example, previously we were dealing with a simple x variable. Now it's time to shift for some complex problem. And instead of using a single variable, this is single variable. Now we need to go to a function based linear model. So for that, let's convert this function. Let's modify this function a little bit. So instead of single variable, let's use predetermined functions such as h of x. So the generalized equation would be like this. So if you compare both of these equations, you can see that instead of x, there is another function. X is replaced by h of x. For example, this one is replaced. This x is replaced by that h of j of x. So our aim would be to find W so that f of x, this f of x, best fits given data. All right. So how it works? So basically, you convert this main equation to this one. How? You just replace x1 into another function named h1 of x. So for example, h of 1x is equal to x1. So you can get this equation from this one. You can get 2 from 1. Okay. So and then, for example, you have another function, for example, x square. So then h1 of x would be x1 square, and so on and so forth. So what is the benefit of using generalized equation instead of a single variable? The benefit of this this generalized equation is you can derive or you can find any model for a given data. For example, you just find a linear model for some given data, and that is underfit. Okay, so if a model is underfit, it means you are not getting the required result or the exact solution. So maybe you go for higher model. So for example, generalized version of linear regression would be this one, as it is explained in the previous slide. So for example, if you use h1 of x as x1, h2 of x is equal to x2, and hd of x is equal to xd, it becomes the same linear equation we have studied before. So this is simple linear regression, but we represent that in a generalized form. How about if we use polynomial regression or second order regression instead of single variable or simple linear regression? So this equation would become this one. For example, if you compare this one with this one, and you see the subscript, this is W0, W0, W1H1, W1H1, and this is WDHD, but this is WD square plus D. Below equation is W is subscript of D square plus D. What it represents? It represents high order equation. Equation starts with, for example, x square plus 2x plus 1. So these are high order polynomial equation or second order polynomial equation, where each one of x would be like this one. So then the function is defined as h1 of x is equal to x1, h2 of x is equal to x2, and hd of x is equal to xd. But when you come a second step, for example, this is simple value for d, but second value d plus 1 is equal to this one, n would be 2d, and the n line or end equation would be h of subscript d square plus 1 into, and the last equation or the last value will be h of d square plus d. So this is equal to xd, this is equal to x1, xd, and this is equal to xd or xd square. Okay. So it means the last term in this case, you see, f subscript is d in symbol form, then hd of x is equal to xd. Similarly, the equation before d square plus d square, the equation would be xt. So it is derived from the same equation. But now you need higher order subscript. So for that, you need more equation. So the equation would be equal to d square plus d value from 0 to d, from d to 2d, and from 2d to d square plus d. So this is generalized polynomial regression second order equation. So why? So this is the same example we have performed earlier for a simple variable linear model derivative. The same data was given to you where you have just x and y variable. So this is x1 and this is y1. Okay, and from that you derive the this model. You derive this model because there were given x and there were given y, and there was given a condition that you have a single variable. Now you have polynomial with a condition of third order polynomial, and the equation gets that, the model gets that complex one. Simple, previously it was just a straight line. Now it becomes curvy plot. Okay, so that's the benefit of polynomial model. Okay, what does additive linear model mean? So the first, that is linear model, then you generalize that linear model, and then fourth one is additive linear model. Additive linear model means that you add non-linear function to the linear model, linear regression. So that is called additive linear model. Adding non-linear functions to the your linear model is called additive linear model. So if you increase the degree order from third to fifth, then it will becomes more curvy like shape. So for example, in this model, this is x data, and this is your final solution, y. Okay, and this is your generalized equation with three function, h3 of x, h2 of x, and h1 of x. And each value, the value of each function is given. For example, h1 of x is equal to x, h2 of x is equal to x squared, and h3 of x is equal to x cubed. So third order polynomial equation is given. No, for example, you think that the given data are periodic. I have already given you that example in last lecture, that if the model is, the data is same, remember the data is same as you have done for your first linear model practice. But now your model is getting complex and complex. What is the main disadvantage of using higher order polynomial instead of simple one? I'm asking a simple question. Anyone would like to answer that? Please online first.
सर अगर हम इसके अंदर देखें ये ज़्यादा मॉडल अगर कर्वी लाइन फिटेड हो जाती है तो इट मीन्स कि हमारा मॉडल ने सारे डेटा पॉइंट्स को जो है ना लर्न कर लिया है। अगर सारे डेटा पॉइंट्स को लर्न कर लिया है तो मॉडल हमारा जो है ना ओवर फिटिंग में चला जाएगा। इसका ये डिसएडवांटेजेस है क्योंकि उसने प्रॉपर
Yes.
जनरलाइज नहीं किया, बस मॉडल ने डेटा पॉइंट्स को मेमोराइज कर लिया है।
Yes. So as Nazar said that this model is overfitted. Apparently, this model would be overfitted. Overfitted means you fit your model to your training data, but you doesn't care about the future data. So that is called overfitting. So that model would give better result on your training data, but that model might give poor result on your test data or your validation data or your unknown data. So that is called overfitted model. And what is the disadvantage of linear model? That is underfitting. So an underfit model call when a model is trained gives poor result on training data. So that will definitely give you poor result on test data. So that is the disadvantage of underfit model. So then in between both of this underfit and overfit model, there is another category called generalization, which means compromise with both underfitting and overfitting and give some model in between both of these, that your model gives you best result in on unseen data. That's called generalized model. So in this case, the model would be your just two function. One is h1 of x, h1 of x, and another is h2 of x. One is simple x, and second h2 of x is sine of alpha x. Okay, so how will you draw this equation? So your next task is to plot this data from this plot from this data. How will you do that? Any comment? You have function, you have model, you have x data, you have y data, and you have final result. But you need to merge this one into to get three. Remember the last mathematical solution we have provided, the matrices solution. Remember that. And what does h1 of, how will you find the value of h of 1 of x? h1 of x. Just put the same value of x here. So here h in h1 of x, your h1 of x would be x, for example. So the values would be 2, 3, 6, and so on. How about h2 of x? Just take the square of this line. So 4, 6, 9, and 36, and so on. So this matrix will be the matrix of h2 of x. And similarly, h3 of x would be the cube of x cube. Okay, simple. And put that value in your previous equation and derive your desired model coefficient and intercept value. Okay, so how to solve this additive linear model? Same our aim is to find W's which minimize the error function. That is the goal of machine learning. What is error function? Error function is, for example, squared error function. And the model equation is, as we generalize it in form of h of hk of xi. Okay, and remember this concept. The x with w0 is equal to 1. So here you will use h0 of xi is equal to 1 to match the matrices for simple mathematics or matrix calculation. And then you have d points, n points, and the data point with n data points with di is equal to x or y, two-dimensional value of x and y, and then input value from xi to xid, xi1 to xid for any I dimension. Okay, clear? So concept is remain the same. This mathematic is same as we did last time. Just previously you have x in the equation. Now you will have h of xi. So this is the error function. That's how you find the partial derivative of that error function. And when you find the partial derivative of error function, you get a generalized equation in terms of. Remember previously here was hj of xi. So you can write that equation where h of xi for w0 is equal to 1. So just you can write hj of xi there too. Because if you replace this for equal to 1, then w0 is need to find w0. Then it will remain the same. Okay. And your model equation is this one. I guess previous in last lecture you have tried the linear regression. So I guess you have a better idea how it works and how you can use this linear regression to find complex model. Same procedure. This is your equation which is open. This one. Okay. As you did for xi. So you actually open this equation, two-dimensional, for I to from 0 to k column wise, and from I this direction and this direction. So you get two equation. So this is the generalized equation we have actually explained in last lecture. So maybe you just repeat that lecture and you will get how this equation is open in terms of summation. Again, same equation, just we just bring out the W's from within to outside. And then you write this in terms of matrices. This is the matrix of a function h, function h, and this is the W's. And this equation is the output y equation with h of x. So after calculation, I guess you can solve this equation if you try, because we solved last equation and you learned that day. So I guess we don't need to spend much time on this derivation and go to the conclusion. So so actually you get, if you see this equation, there are two h. So similarly, and one w. So this is H transpose with H transpose, and W is matrix is this one. As similarly, this is H matrix, and this is Y matrix. So we wrote this in form of matrices. क्योंकि मल्टीप्लिकेशन जब आप मैट्रिक्स लेते हैं, फॉर एग्जांपल ये आपके पास मैट्रिक्स है, एंड ये आपके पास मैट्रिक्स है, इसका मतलब है कि ये आपको क्या रिजल्ट दे देगा, अच्छा, इसका मतलब होता है कि करस्पॉन्डिंग डिजिट को मल्टीप्लाई करें। तो ये 1 से मल्टीप्लाई होगा, 2 से मल्टीप्लाई होगा, 3 से होगा, तो आपके पास ये मैट्रिक्स आ जाएगा। तो इस चीज को करने के लिए आपके पास ट्रांसपोज होना चाहिए ताकि आपस में मल्टीप्लाई हो। ठीक है, तो सिमिलरली इसी को ट्रांसपोज के फॉर्म में लिखा हुआ है। अगर अगर आप इसको देखें, इसमें भी एच आपके पास ट्रांसपोज में है, और वाई आपके पास सिंपल है। रीजन ये है, अगर आप इसको देखें, ये लीनियर है, रो वाइज है, और ये कॉलम वाइज है। तो जो कॉलम वाइज है उसको सिंपल रखा हुआ है, और जो आपके पास रो वाइज चेंज हो रहा है वो उसको आपने ट्रांसपोज के फॉर्म में लिखा हुआ है। एनीहाउ we get the H matrix, which is H is the functions matrix of functions, H0 to HK, and H0 to HK for 1 to n, and this is W matrix, and this is Y matrix. So when you need to find W, just similar concept, just take the inverse derivative inverse of this matrix and shift it to your right, and then you will get the value of W. So you will get this equation in the end. H transpose into H, all inverse, and H transpose into Y. And this is the matrix you will find from the given data. And of course, output is given. So now we will solve this equation this way. You have this one, this data, and you have this Y output. So H1 is simple X, so values will remain the same. H2 of X is X square, so take the square of all these values and make a matrix of that. And similarly, take cube of these X and make a matrix of that. And that's how you find the W, by putting your value in this equation. After this, you will get these values, and your model will become this one. Clear? So if you see the equation x cube, x square, and x. 1 second, please. 1 second, please. So your model would be x cube, x square, and x, and plus W0. So there are 4 values, 4 different type of uh, intercept point, you can say. So that's how your higher order model is derived. Okay, there was some question I was listening. Any question?
अच्छा सर, मेरा क्वेश्चन ये है कि एच मैट्रिक्स जो अभी आपने H1, H2, H3 का कहा है, उससे एच मैट्रिक्स जरा काइंडली जरा आप बताएं कि किस तरह से हम जो है ना वो इससे एक्सट्रैक्ट कर सकते हैं जो एच मैट्रिक्स है।
अच्छा, आप कह रहे हैं कि इस डेटा से मैं एच मैट्रिक्स कैसे निकालूंगा, यही कह रहे हो?
जी सर, जो H1 और H2 और H3 के फंक्शंस गिवन है, तो इससे हमारे पास एच मैट्रिक्स किस तरह बनेगा?
ओके, मैं समझ गया आपका क्वेश्चन. So for example, h1 of x is x. So how will you find this matrix? Simple. Same. 2, 3, 6, 7, 8, up to last term, which is 18. How will you find h2 of x? That is x square. So I'm writing this capital, which shows a matrix. Okay. So that will become 4, 9, 36, because you are taking the square of each value. 49, 64, and so on. So this is the value of h2 of x. Now you want to find h3 of x. Just take the cube of 8 27, 6, 36, and 6, 216. Okay. So this is the value of H3 of X. You have you gotten your point, Asif?
सर यहाँ तक तो क्लियर था। जो कैपिटल एच हमारे पास जो फॉर्मूला में है ना, वो इससे किस तरह एक्सट्रैक्ट करेंगे, या हम इसी को यूज करते
This is
हुए एक
actually
वैल्यू को कैलकुलेट करें?
okay. So actually, what I have calculated is capital H. This is actually H1 of X, which is consists of H1 of X1, H1 of X2, H1 of X3, and so on. So the very single value, for example, square of 2 is 4, which is H2 of X1. Clear?
जी सर, अभी क्लियर हो गया सर। इसका मतलब है कि जो स्मॉल h1 है वो एक फर्स्ट रो
वो
है
सिंगल वैल्यू,
कैपिटल h1। जी
वो सिंगल वैल्यू को रिप्रेजेंट कर रहा है। वो जो सिंगल वैल्यू का जो फंक्शन के बाद वैल्यू आएगी, दैट इज एक्चुअली स्मॉल h.
ठीक है सर।
Clear? So that's how you find this model, by putting values in that equation. And you see, can you see the difference with the simple linear model? You see, can you see this difference between the points touched? And when you check linear model, this one, so it means the difference is decreasing actually. Difference is too much. Okay. So that's how it shows that it is learning more points than a straight line. So you want to you say that this model is still underfitting. For example, you experimented with this model and you see that it doesn't look good on unseen data, or maybe you are trying to find some, because if you see this model, then it's a kind of periodic. So you check either periodic function looks bit or gives better result compared to the linear model or polynomial model or not. You just check for that. So for that purpose, same data is given with X matrix and Y matrix, and this is the your model function where h1 of X is equal to X and h2 of X is equal to sine of alpha X or AX. So when you put all these value in this h1 of X, so your h1 of X will be the same as X, but your sine alpha X will be different one, and alpha would be some constant value. See this kind of equation. One is alpha, and this is, so this is actually amplitude. This is your frequency, or give it this one. So this is equal to your theta, and this one is your phi. This is phase. This is your frequency, and this is your amplitude. Amplitude means you are just amplifying your frequency, and phase means you are shifting the transition of changing your direction, or phase shifting your plot. So this alpha is just an amplitude or amplifier, some constant value. It might be equal to 1, then it will not affect our equation. So after using this alpha and this equation, the result we achieved is this one, and this is our model. this model or this equation gives this fitted model. But we don't know either which model is more better on unseen data. Either this model or the one we tried previously or the one we tried initially. So that will be checked upon the unseen data. Then there comes some more interesting. What is a kernel? Kernel means some specific equation. Specific equation. Have you practiced or have you seen before normal distribution, PDF of normal distribution or exponential distribution? So if you see exponential distribution or normal distribution, the plot of normal distribution would be like this one. Okay. So these kernels are actually taken from the normal distribution. You remember normal distribution? I guess you have read in your probability theory course, Gaussian model or Gaussian model. So these kernels are taken from that distribution. For example, this is difference is this one. So please check the main equation of exponential distribution. So that is some kind of mean minus sigma divided by something like that. This is the equation, and 2 lambda. So actually these are value taken from that equation where you set your mean, your standard deviation and variance, and put that in your Gaussian distribution. So these equations are taken from there. If you check that equation, then you see that 9 and 1 are those value. So just we will try, for example, what is the impact of kernel regression. So the data and output remains the same for all till this slide. And these are your linear model, and where h1 of x is equal to this equation, exponential of minus x minus 1 whole squared divided by 18, and h2 of x is equal to, so only difference is in the above space. Okay. So if you put the values in this equation, all this, you will get this model and this fitted plot, and this is your desired model or equation after using specific kernels. And you see that how it is different than the periodic. So if you compare the linear model, the polynomial model, the periodic model, and then kernel model, there are 4 different models are tried. To compare the fitted model with each other, which model fits apparently more good than other, or which fit model learns more data point. Actually, this is the Gaussian model values from which these kind of things are derived from these points. For example, this is referred to this one, this is referred to this one, and this is referred to this one. So the curve or the normal equation is expressed in your fitted model, because this might give you this one, and this might give you this one, and this might give you this type of model. And when alls are add up, you get this kind of fit model, fit model fitted for that data. So these are kernel-based regression. Another approaches. So how we solve linear equation? You have tried many methods. One is simple approach for linear regression by solving linear equation. Your first problem, or first assignment. Second one was using gradient descent method. And third would be or is based on maximum likelihood estimation approach. That is probability based approach. That could be another one. Then why? So both these approaches are well known. Both are well known, useful and important method to solve problems in machine learning domain. So why we use one equation, then we do not use another equation? Maybe you do not solve, or you cannot solve your problem with one solution. If this solution exists, then you will try this one. But if your variable increases to 1,000, then it might be difficult to handle those kind of equations. Then you use gradient descent method. Both give the same solution as simple linear equation. So summary, we have studied linear regression and then additive linear model, where we have studied polynomial model and then additive linear model. Last equation was kernel regression. So this was all about your regression problems. Any question?